Howdy everybody in YouTube land. So what we have in front of us today is a TV. So we actually have a TV up on the bench for repair. Now this TV, this one's mine, and this board is not the board that went into this TV. So the backstory is a friend of mine got a 13-inch version of this TV, Sharp Linytron something or another, and it has no color. So he replaced the chip, and then he replaced the crystal, and it didn't make any difference. He put some new caps in it, as you can see. This one over here was the worst one, but it's all been replaced. Still no color. And that's when he decided to send it to me. Interestingly enough, this TV also failed, and it was running, and all of a sudden it just died. And we'll get to that later. But I figured, well, since I got to fix this TV anyways, I bet this board will run this tube. And it may not run it right, because this is a 19-inch tube and not a 13-inch tube, but this board should run this tube. So I can diagnose the fault and figure out what's going on with my TV, so he didn't have to ship the whole TV, just the board and the tuner, because I didn't know if my tuner was compatible, and it looks like it's very similar. The difference is they both have this 4-pin connector here, but on mine the IF line uses an RCA cable. On this one it uses this JST connector, so it's not directly plug-inable, I should say. But other than that, the tuner is the same, as you can tell. So, alright, without further ado, we need to get this thing hooked up to the chassis, and we need to kick it on. I have a pair of rabbit ears over here, because in that room, you can barely see it, but in that room, I have the equipment rack running, which is transmitting an OTA signal right now, so I should be able to pick that up in here and use that for diagnosing what's going on. So let's get this one hooked up and see what we got going on. So alright, so everything's just kind of plugged in here loosely at the moment. Got the tuner plugged in. This is just dangling over there. I took the original ground wire off so I can make room to plug this one in, because this is in a different spot. And I had to tack it over here because it wanted to be over there, but it's not going to fit over there. But I had to, because this flyback lead is so short, I had to elevate the board up, because again, this board was originally designed for a 13-inch set and not a 19, or maybe it was a 15, I don't remember. So here we go. It's either going to work or it's going to blow up in a ball of flames. So let's see. Wait, it's down here. It's on. Hey, we have a picture. Very dim, but it's not surprising. So, okay, let me get the antenna hooked up. Alright, so I got everything wired up. I don't have the plugs for these, so I ended up soldering the balun connector right directly to the joints there for that. It's connected into my antenna, set to channel 5, and I have a picture now, but there's a lot of ghosting, and it's not correctable by the fine tuning. Now, you can really see it with the Y here. Now, if I turn off, there's an AFT button on this board, and if I turn that AFT off, it's just pure snow. It won't come in. So I think, could be wrong, but I think what we have going on here is a tuner or IF problem, but not so much a color issue, because over here it's not as prevalent as it is here, but you can see a double Y. There's something going on in that circuit, and of course there's no color. That was the original complaint, there's no color. But I think that's why there's no color, is because we have there's something going on with that. It's not supposed to be doing that, not at all. So yeah, now I have to get down to the bottom of that. Now unfortunately, I do not have the correct equipment to work on things like this as much as like Bob Anderson or, Shango 066, stuff like that, because I don't have the IF signal generator set up or any of that. I could just go straight into the IF and eliminate the tuner. I don't have that. I don't have that capability. So it's gonna be a little fun trying to figure it out, I think. But in time we'll get there. It's just gonna be a little bit more challenging. So next steps. What should we do next? Well, I think we should take a look at the tuner or try to push a stronger signal into this thing somehow and see if we can't clear that up. But with what, I don't know yet. I think I do have an RF signal generator. It's like an SMPTE crosshatch, etc. that gives you like channel 3 out. So I have one of those. I think I can try that. So the good news is I found the SAMs to that particular television. As we said earlier, it will not tune in anything at all if the AFT button is not engaged. So we know, we can make a reasonable prediction that there's something wrong in the front end. And the reason why we don't have any color is because the signal coming in is just too weak. It's being lost. So, I wonder, let's see, because we know that this is the front end here. Well, this is part of the front end. Audio output, IF amp, IF AGC. We got some voltages here. So we have that. Okay, from tuner, there's the input jack, there's a coupling capacitor, and there's the amplifier. Now, there's a filter here, but there's no oscilloscope shot, which I don't like. So, let's see, Q201, which is a 2SC 1906. I could do some voltage checks there to see if we're good on that. Then we have a ceramic filter, which is probably filtering out the sums and differences of the IF. So I think it's a 45 megahertz IF. I could be wrong. So this is probably a 45 megahertz ceramic filter. So we should have something there. Now there's TP200. Okay, so I wonder if there's a shot for TP200. See, RF AGC range, 3.5 to 7.7 volts. So we have something to go off there, because we can look at the automatic gain control line and see this cap has been replaced, so it ain't that. But I can take a look at some voltages here to see where they are and to see if they're on par. Because the other thing too is we also have my tuner, which did work as far as I know. So even though the IF input jack is different, I could actually use this tuner and, get a couple of clip leads or something. I can use this tuner and roll this out 100% just to make sure that we don't have a problem here. But before I do that, I'm going to do some quick voltage measurements and see, because this is the filter right there. That right there is the filter, and this is the RF amplifier transistor, which is indicated right here. So, I'm going to go ahead and do some quick voltage checks and roll that out real quick. Using my analog or digital multimeter over here, I did some quick checks, and what I found so far is these are both about 5.3, so they're dead on. This is about 9.1 volts, so it's good. All the voltages are good. However, this AGC feedback line says range of about 3.5 to 7.7. I'm somewhere between 3.4 and 4.0, so it's on the very bottom end of the AGC range. What that means yet, I don't know, so I need to look at the chip. If I can even find a data sheet to it, I don't know, but I gotta see which direction this is supposed to go. If it goes up to the 7.7 volts if it's too weak, or does it stay down here if it's too weak? Not sure, but we'll figure that out. AGC voltages, they use 0.5. or pin number 5 on this chip here to test for that, and I checked it, and it's where it said it's supposed to be. So, all right, it says right here for the alignment or the adjustment, it says tune to medium strength station to adjust to set the normal picture. Set AFT switch to off. So, what I've noticed, because right now it's on, AFT is on, so I should have a picture. I do, but the minute I turn this guy off, which is now off, it's just barely coming in. So what I'm going to do is I'm going to perform that adjustment procedure, and well, first I'm going to adjust the fine tuning, and then I'm going to perform that adjustment procedure. Once I know that's good, I will proceed with the color troubleshooting, because it does have a chart here. So we're going to do that next. We might be getting somewhere, because we have a problem in the AGC, I think. Because if I turn the AFT off, as they say in the SAMs to do, and I go to try to adjust this with minimum snow and no overloading, if I turn that knob, it has zero effect on the picture. Zero effect whatsoever. So, I want to restore that back to where it was, which is right there. So now we need to take a look at the schematic and figure out, okay, where does, see, that is just R609, okay, no, R215. Yeah, that's right, so R215. So let's go on the schematic here. Let's figure out where R215 actually is. So there it is, AGC, which is 3.5 to 7. No. It's here. So 10. Okay, so this adjusts a voltage here. So I assume at this point we need to see if we actually have a voltage there. Because if that's not working, the whole thing's not going to work. Because you can't troubleshoot the color stage until you have a proper RF signal coming in. So that's pin 10. It shows 5.7 volts. So let's see, 12, 11, 10, which is right here. That's right. So let's do that. I want to move that down. Just randomly adjust it. Do it again here. Yeah, that's right. So it's working. This circuit here is anyways. Doesn't mean there's not a problem in the chip. There could be an issue there. There could be a lot of issues in a lot of places. I'm just guessing at this point because... Okay, so we can't adjust the AGC because there's a problem clearly somewhere. Now, the strength coming out of the tuner could be just too weak. That'll certainly do it. Because from what I understand with the voltage checks, it's when I turn that switch on and it works, it's slamming the AGC off to one side. It's like bang. So if I don't have a clean enough signal coming through, even though this chip is compensating for it when I turn this switch on, when I turn this AFT switch on, it tells this chip to, whatever. But the problem is if I don't have a good signal coming in because of the tuner or something else, it's going to be impossible to get color out of the DMOD. So, yeah, we got to figure that part out. Alright, so let's make this one more fun than it already is. So I have this tuner wired in now. Plug the power in. So on the IF input, what I did was I soldered a couple cut clip leads and connected them there. It's probably not going to work right, but we'll see. Let's see if we get any smoke. Hopefully this tuner is somewhat the same. Alright, let's see, what do we get? I mean, the tuner works. Nope, not there. No, it's still weak. So there's something wrong. There's something definitely wrong with the front end. Let's kick this back on. Let's see. Yeah, see? It still has a similar problem. Yeah. Alright, well, that's not going to work. No, is it? Well, we can effectively rule out the tuner. So that's a good thing. It's definitely, it's weird, it's overloaded. Oh yeah, it's overloaded. Yeah, there's definitely some overloading issues there because look at that. When I kick the fine tuning control up. Yeah, see that's... Yeah, that looks normal. Yeah, that looks normal. That's overloaded. Yeah, that's better. Yeah. Yeah, it's not... No, that's overloaded. That's not good. So, now that I've swapped the tuner around, let's see if this AGC control does anything at all. Yeah, okay, that's too strong. That's cranked all the way the other way. Yeah. Yeah, that's not bad. Alright, yeah, that's better. It's not good, but it's better. Overloaded again. So let's bring her back around the other way. Yeah, it's not supposed to overload. That's weird. Yeah, there's something definitely wrong there. If the front end's not working right, it's never going to have color. So that is likely why we have the color problem, because the front end's not working right. Yeah, let me see that. See how it's just like blah. It's overloaded. That's what's causing this ghosting. Because if I bring it down, I can try to... Now it's not overloading anymore. The AGC just kicked out. And that's what happens when the AFT kicks in. It's not supposed to do that. There's something wrong. So, that's with the other tuner. Now let's kick this off. See? It's definitely... That's the cleanest point right there. So if I go into this AGC setting again, yeah, it doesn't do shit. So alright, well. Okay, so when I kick on the AFT, boom. Yeah. Alright, well, we got some further troubleshooting to do on this one. Alright, after playing with it for a little bit, it's not terrible. I mean, it looks like it's overloaded, but it might be normal for these. Because now it's just too dingy. And this is what happens when the AGC locks in. So, I tweaked it a little because this is a different tuner. So when I hook the other one back up, I'm going to have to retweak it again. I also tweaked the CRT focus because, like I said, this board was not for this tube. So this CRT is for that board over there, not the one that's hooked up in here. So, but that's fine. Alright, so I'm just going to leave the front end alone right now because, I mean, it's coming in really clear. At this point, I need to start looking at the troubleshooting section for the color stage according to the SAMs and see what we can get there. So I think in order to do that, I've got to go ahead and just get my multimeter ready, turn it on, and you know, all that fun stuff. So we get that ready. Then we move you out of the way because you are like in the way. I need a... this setup is not ideal. I got to figure something out here. But in the meantime, let's get this scope set up so I can look at the oscillator. Because I need to make sure the 3.58 megahertz oscillator is even running. Because if it's not, it ain't going to work. Hello, Mr. Stinkbug. You just kind of like came out of nowhere. Hi. Alright, so let's get everything ready to go. I just made the rookiest mistake in the whole wide world. So you can kind of see where this is going. So I totally forgot about the scope and its isolation. So as soon as I took this guy and touched it to the ground, it arced and blew the fuse. So I guarantee it destroyed the regulator and the B+, I don't know. So yeah. Well, that was a rookie move. Tisk, tisk, tisk. So I threw a fuse in it, it blew it again, so I grabbed my light bulb tester and it was lighting up bright, and that's when I realized one of these 4 rectifier diodes is shorted, so I'm going to replace that. But I've noticed when I was probing around, look at this. There's a diode right here, D706. It's broke free completely from the board. There's your problem. I wonder if that's why the color doesn't work. Oh, right away we have D706 that's completely broke free from the board. I mean, it's just not even on there anymore. D705 is not far behind it. And I'm noticing some sussy areas over here. But that's the only thing that's standing out to me at the moment. So let's take a look at the Sims. Oh, we got one here too. That was... Oh, Brian missed that when he put the caps in. And this one too. Oh yeah. There's some serious issues going on here with the recap job. Yeah, that is busted completely off. Ooh, you gotta be careful when you do this stuff. Anyways, it's not that big of a deal. I can patch that up. But so I want to take a look at the schematic here. D705 and 706 are fed. So let's see, there's the flyback transformer. So we have 705, which will feed this 18 volt source. But if 705, if R715 ever went open, 706 will feed that out. But it can't go the other way. So 706 supplies the 12 volt source. So this number 4 12 volt source is supplied by the flyback. So where does all of this go? This is source number 4. There's also source number 7, which comes off of 705, right? So let's see, where does 4 go? Well, we got 7 here. We got 7 here. We also have 7 here. So this jungle chip is powered off of 7, but where does 4 go? Well, let's see. I need to take a look at 4. So 1, 7. There's a lot of 7s and 1s. See, there's some 6s, but I can't really tell where 4 goes. Okay, 4 goes the audio out, so we won't have any sound if that's missing. See, 6, 6, 7. 7 powers this. So 7 is used in a lot of places. Let's see. 6. I only see 4 going to the audio amp. Let's take a look at the vertical output. Because 4 goes somewhere. I don't think that might... I don't know. That might not be my color problem. But 7's going there. 3. 3. So the issue is... 4. Where do you... So 4 supplies, but it also feeds 5, 6, and 7 if D705 is not operational. So we need to check 716 and 715 and make sure they're still connected, so, or not blown open. So see, 715 and 716. So 716 is an issue because we have some broken solder joints there. Okay, 716 is good. So 715, where are you? Right here. Okay, 715 is okay. So the diode or the resistors are fine. So 705 was functional, which makes sense because we had a picture. Without, if 705 wasn't working, we would have a picture. So we know that rail is good. Now this 12 volt source, which is Zener regulated, that resistor's not open, but that certainly is. And the only place it goes, as far as I can tell, is the audio. So I didn't test the audio, so chances are we would not have sound if 4 was not. Anyways, I need to get this diode in place and get it all fixed and try to get this thing fired up. The more I look at this board, the more atrocious it actually is. And I've been patching them up left and right. And the suspect ones, you can just touch it and the solder just vaporizes. So, everything that stood out to me, I went ahead and got. There's probably a bunch more on this board. I know there is. So, half the issues I have going on could be related to the fact that it's just got garbage solder joints. So, in the meantime, I replaced this diode over here. So, I'm going to try it. I mean, it'll either work and I'll be back to where I started, or not. Let's just hope it works. Dim bulb tester's in. Running at about 106 volts, 107 volts all plugged in. I got a 10 amp fuse in there. It needs to be a 4 amp. The only reason why I'm doing that is because I have this light bulb load in the middle. So there's a load there. New diode is in there. And I fixed all the solder joints that I could find. And there we go. We're back to at least where we were before. So we're not, we're not dealing with my screw up. So that's fixed now. So now I'm waiting for the battery to charge on this scope so I can run an isolated scope, but I don't know if it's actually going to charge. Nope, the battery's no good in that thing. Alright, well, anyways, okay, at least we're back to where we started. Alright, so I got a new fuse in there, I got the new diode in there. This board is working fine now, so I had to drag up this scope, which I've used in a lot of my previous videos. This one's isolated, so I had to wait for the battery to charge just in case. But yeah, there's no path to ground from that plug to this. So this scope is 100% isolated. I just don't know if this is going to have the resolution to see what we need to see. Now, I have the probe connected to TP801, which is this guy right here. So this coil, I think this is a chroma filter. So there's 12 volts here. There's the waveform that's supposed to be there. And then there's the waveform that's supposed to be there. 0.3 volts, 10 microseconds per division. Which is, I got this set for 100 microseconds per division. So let's 10 microseconds per division. And then we are 0.3 volts, so we got 1 volt here, so we need to move that down. Actually, no, we'll leave it at 1 volt. So DC coupled 1 volt, etc., etc. So backlight is on. I could turn it on and off, but it doesn't really make much difference. But so okay, there's our test point. We should have something that looks kind of like that. So I think this, I'm not sure where the delay line is, if it's built into the chip or what, but I know with NTSC and Chroma and Luma, you got to have a delay line. So this circuit this is probably the demodulated Chroma out that goes in here. So if we're missing this from the signal, it's not going to work. So I think we're set up for that test now. Now, it's either going to work or it's going to blow up into a ball of flames when I plug this in. Nope, it's on. Yeah, that's not normal. I just got noise. There's just noise there. So, again, this could be an IF problem. This could be a problem with the DMOD that's in the chip. Now, the chip's been replaced, so we can roll that out. The crystal's been replaced. Didn't make a difference, so I put it back. We don't have what we need to see there. So, this peak to peak is 0.3. Let's see, what's the... Yeah, there's some stuff there, but it's not really legible. Just noise. All it is, noise. Alright, well, that might be normal. I doubt it. I don't think so. I think we're supposed to have the burst there. So, chip is not demodulating, but now pin 4, which is R413, has this. So let's take a look at that. Now, it's entirely possible I have to push a color bar signal into this thing. Because I'm just using some random OTA signals. So I'm going to go get my color bar generator. But by looking at this, it kind of... Get that out of the way. It kind of represents that, but not really. They don't tell you what they're inputting in as far as a signal when they're looking at this. So I'm going to assume it's probably a color bar generator. So let me go grab that out of my junk bin. Don't know if it works, but let's go grab that and see what the color bars do. Well, I have my color bar generator, my 1211B, but guess what? I don't have that cable. So, axe that idea until I can maybe rig something. And it's not a standard 3.5 mil because that's a tinier one, which I don't have at all. So, I do have the schematic though, so I could probably rig something. Alright, problem solved. I just took a BNC to clip lead adapter from Pomona or whatever, cut the end off and soldered it directly onto where the jack used to be. That way I can just clip lead it in place if I'm ever working on something. So now, if I kick it on, it's got a battery inside. Boom. So there we go. That's supposed to be the color bars. So we have no color bars. Now, I'm going to assume, if anyone that's watching this channel is watching Shango066, he had that little vector scope that had the clover leaf when he's troubleshooting TVs. Well, that's what this pattern is for. It generates the phasing. So now we have that, and I'm pretty sure this was based off of that. So we're going to use that to set the scope. So let's take a look at the scope now, see what we have. Yeah, there we go. See, that makes more sense. See? There's that. We have that. See, that makes more sense now. Turn the backlight on so we can see what we're doing. Yeah, that makes more sense. Okay. Now we're getting somewhere. So that's our color bars, and there's this, I don't know what that is. I think that's color bars, and that's a sync signal, or the burst signal. So the burst is being picked up. Now, that's this point right here. So we need to move back down to this point here. So let's do that. Let's go ahead and do this hot, which is a very dumb idea. TP801, it's actually labeled on the board. TP801, what do we have? Nothing. So I've got my probe now connected at R812, which should be 1.5 volts at 500 or 0.5 microseconds per division, which I've got at about 0.2, which is close enough. And sure enough, 1.6 volts peak to peak, roughly, and we're running at 3.57 megahertz. So the oscillator is running. so we can roll the oscillator out, which that's a good thing. So the problem is right here. We're getting what we have over on this side, but we're not getting what we need on this side. So we've got an issue in this section here. So that, I think, is the delay line, and that's a tunable delay line, which is this adjustment right here. But and I can see its adjustments beat all to death, so that has me kind of worried. But then we have T801, which is this one right there. So we're not getting a transfer of signal across this circuit, so we need to find out why that is. So step one is to see if any of these coils are open, which is going to be hard to tell because there's a cap in the way on that one. So I might have to pull the two inductors out and check them out of circuit. I'm getting ready to pull the board so I can start checking the inductors and the resistors and things for opens and stuff like that. But I want to address something because I've had a lot of controversy over this, including people, yelling at me in the comment section and stuff like that about discharging a CRT. So typically you can take a screwdriver and clip lead and connect it to the DAG ground and stuff like that. But now I've got this high voltage probe, so watch what I'm going to do. I'm going to turn this on while I slide it up under the anode cap. You can see how much charge there is on that tube with it off. Now, this thing, with this like this, it's while I keep it under here, it's kind of safe to remove that cap right now, which is what I'm going to do. But I want to teach you a little thing called dielectric absorption. So now that's discharged, I can pull that anode lead. It's completely out of the way. So it's safe to remove the circuit board out of the way. Now, the reason why I want to bring this up is there's a phenomenon called dielectric absorption. So what happens is now everything's been removed, right? It was safe to remove it. I didn't get shocked or anything like that. But now that it's been sitting for a second, if I turn this switch back on and touch that cap again, you see that little voltage creep up right there? And if I let it sit some more, I'll get more voltage creep up. I can still feel the static clean. So this has absorbed energy. Even though I discharged it, it's not a perfect, it's not a 0 ohm infinite, ideal resistance. There's literally resistance all throughout this entire CRT. So even though I discharged it, it discharged the CRT, but there's charge on the other side that has not made it this way yet. It takes time to migrate. So what's going to happen is the CRT is going to retain a charge continuously until the dielectric has been, all charge is drained off the dielectric. So if I do this again, yeah, there it is. There was about 2 kV there that just discharged. See, dielectric absorption. Keep that in mind. So I did some checking on the solder joints, and I checked a bunch of resistors and capacitors and stuff in here, and they're all fine. I'm not seeing anything. I checked the transformer, or this is the bandpass filter, this is the delay line. Now what the delay line is let's say if you have a bright, like an orange or blue or whatever object on the screen, the chroma and the luminance information are not coming in at the same speed. So this adjusts how much it leads or lags the luminance. So what ends up happening is, let's say if you got an object and your color is too far this way or too far this way versus the object itself that's in the black and white image, that would be set by this, the delay line. So, and it's adjustable. However, since we have no color, we're missing color information. So I checked the resistances in here and here. It's all fine. I'm not seeing anything. Nothing's standing out to me. There's shield that goes through the circuit board with this guy. There's a crack in one of the traces, but it's actually still connected. Couldn't find any other cracks, any other damage or anything like that. But now, reviewing the footage before making this take and then looking back, I remember when I was probing this signal right here, I was getting something more like that than this. Like the amplitude of these peaks is a lot lower, more like this than this. So I'm wondering if I'm missing the color information going into the chip for some reason, which would continue to point back to this IF stage. The problem is I don't have the proper test equipment to generate like a 44 or 45 megahertz signal to inject right here to avoid all of that. I don't have the right equipment, so there's not much I can do at this point. And I don't really work on enough CRT TVs to invest in equipment like that because this stuff has gotten expensive and hard to find. So a sweep marker generator, a television analyst, that kind of thing is just it's gotten crazy expensive. So, anyways, so there's the IS stage. We got filters and blah blah blah. But I remember getting more. Although the amplitude of that's a little lower than that. So maybe I should check this. So maybe we should go back a stage and check this. Because I checked that, if you remember. And the amplitude of those peaks was a lot lower than what this is indicating. It looked more like that. Which would be missing the color information. So, I don't know. The other thing I can do, potentially, it's not going to work right. I could take a jumper wire and go from here to here and bypass the entire bandpass stage. Not going to work right. Might look like crap, but we'll know if the chip is even activating. Because the issue is, if you look at this here, is we've got a automatic, automatic color correction amplifier, blah blah blah, automatic color, whatever. But then there's this killer circuit, which is the color killer. And that is these guys over here. It's connected to these filter networks, but yeah, I'm not sure where to go from this point. We know the oscillator's running. The signal here is super weak. It's there, but it's weak. And I have a feeling that is part to do with it. But my chassis, I could steal parts off of that temporarily to see if it's going to solve the problem. But, So, now I've got the scope probe here on R404. And it should look relatively something like that. 2 volts, 10 microseconds. So, we will set this to 10 microseconds. So, here we go. Alright, so 2 volts, or 10 microseconds is what we're looking for. So we have 10 microseconds, and it kind of looks something like that. But look what we have going on here. 800 millivolts, peak to peak. So we have 800 millivolts roughly peak to peak with a sync pulse. That's supposed to be 2 volts. That right there is a problem in and of itself. So the output from the IF is weak. It's very weak. It's less than half of what it should be. So if we turn the time base down, we can see the color information that's in the signal. So I'm not sure. It's not going to calculate the frequency that well. That's the only problem. So it's not gonna. It's trying to. So that's the burst frequency. So, anyways, the color burst information is there, but yeah, the color burst information is there, but it's just not. Color burst information is there, but it's weak. It's supposed to be double what it should be. So when I turn the voltage up, yeah, 900 millivolts, supposed to be about 2 volts. So division's half a volt. So yeah, if I move the cursor up, yeah, not even a volt. Not even a volt. So yeah, it's an issue. Alright, well, there's our problem. The IF's too weak. Alright, so with a little bit of poking around, here's where I'm at. It's set on color gradation here. There's the line frequency, the horizontal sync pulse. There's supposed to be a color burst 3.5758 megahertz on this bar, and it's not there. This is probing right off the IF. Right, I've got the probe right here on L207, and we're not getting it. So, but if I probe this directly, set it to video and connect these up to the scope directly, I can actually get the color burst there. It's visible, but it's not visible through the IF. So, and we're only about a volt peak to peak versus the 3.4 we're supposed to have. So what I'm going to do next, I'm going to grab my board, unhook the horizontal output transistor because it's shorted, but I want to grab my board and probe the same thing here, because I'm curious if I get the same amplitude, the same situation from the same tuner. Because if I don't, if it looks much better on that one, then I know I have an IF problem. So now I got my chassis hooked up. I had to replace 2 diodes, the fuse, and the horizontal output transistor. All the old crap's just kind of sitting there. That was a rig in. So that's all out of there now. I got that one wired up, and I actually have color. That's what I'm supposed to get. So with that, I now have a control. So I can actually hook the oscilloscope up and see. I can see, what the expected waveforms are from this generator. Take pictures of it and save them so I know, okay, well, this is how it's supposed to be. Also it doesn't have as much snow as the other one did. So that makes me wonder that the IF circuitry on the other one is screwed for some reason or another. But anyways, let's get the scope hooked up to it, and we'll do some measurements with the working one so we know what our control is. As I was getting prepared to run the next set of tests here, I I went to plug it in and it blew the fuse again, and it shorted 2 more of the diodes again. And the reason why is the resistor, there was a resistor here, is missing. It's just been bypassed by the former person, so that is likely why it's blowing diodes every time I power it on. So I'm going to simulate a resistor by using my light bulb. So let's make sure it doesn't explode again into a ball of flames. It probably will, but actually no, it kicked on. Make sure we're still good. Alright, good. Okay, so now hopefully we can do tests again. Oof. Alright. This is becoming a problem. Okay, so I'm going to do another TP801 test first. And I'm going to do a test right here on 413. Like we did before. And remember what waveforms we had before. So then we're going to do a comparison. What I found interesting was I tried to measure here and I couldn't get anything on the good one. So I'm back here, which says 1.7 volts 10 microseconds. So peak to peak is only about 0.6 volts. So it's half of, well, less than that on this one. But it's give me basically the same output as the other one. The difference is there's a little bit of a grade here. So let me switch it over to purity. And yeah, you can see a slant where the other one didn't have that. So there's a difference there. But other than that, the result is exactly the same in the same spot. So let's go back a stage. Let's go to the IF and see what we have there at the IF. And see what we have there with the voltages and all that stuff compared to what we had on the other one. So I am at the let's see, TP401, I'm pretty sure. Right before the filter, on the other side of the filter. So, and that's the response that the other one was given. About 1 volt. So it's roughly the same. I'm not seeing much difference at all. And there it is. I still have color. But what I did find out, if I turn off the automatic fine tuning control, it's a lot clearer without the AFT compared to the other one. So there's something wrong in the other one on that. But if I adjust this, I'll lose color. Like, it looks clean, but I've got no color. But there's a point at which it just kicks in where the other one doesn't do it at all. So there is an issue, in my opinion, in the IF stage that's causing an issue on the other one. Even though I'm not seeing the response on the scope. Yeah. So my output's the same, really. Everything looks the same. So my scope may not be responsive enough to be able to detect the subtle differences, though. That's the downside. But anyways, using the light bulb prevents it from blowing up again. So I did a composite injection right here, which is this point here. And I was able to get the video to come up. This pin has to be biased at a specific voltage, but there's still no color. So what I'm going to do is I'm going to take the jungle chip out because it was already replaced, but I don't know if the one they put in there was bad or not. I don't know. So we're going to take the jungle chip and we're going to take both of these coils. One of them is the band pass and one of them is the delay line. And I'm going to move them into my board and see if it will demodulate color. Because then if I lose it on my board, then I know we got a problem with one of those three. Alright, so both coils and jungle IC has been removed off the board. And now we're going to move that over to my functional board, and then we're going to see what happens. Alright, so here we go. I got the chip and the 2 coils in from the non-working board into my board. So we're going to see what the hell happens. Alright. Do we have anything? We do. So demod works. It's not the chip or the coils. Alright, so this picture's a lot cleaner as well. It really is. So what I'm curious about, how much... Okay, so it's not those, so we can roll that out. Let's see. I'm curious how much of this is affected. That's even off a little bit too. It is, just a tiny bit. It was ever so slightly off. Come on, get in your hole. I won't go in the... I can't get it in the turn pivot. There it is. Yeah, it's not. Alright, anyways. It's not really... Yeah, it's not trying to... Anyways, I don't want to mess that up too much more than what it already is. So, yeah, demod is not an issue. So let's just kick this over here. So demod gets lost. And then, see, now there's no demod. But then it just locks right in. Yeah, it's fine. Perfectly fine. Alright, so that rolls out the jungle chip and the 2 coils. Just to roll out, it's my method. What I did was, again, I have composite video on the generator, and I'm connected into R403. 404 I'm using as a ground, but I'm using 403 as the composite input, which is pin 6 here on the jungle, right where that waveform is located. I did that on the good board with the original coil and stuff from the bad board, and I got demod. Now, there's IF noise coming in because the two are coupled together, but composite will demod. So, that rolls out the entire IF stage on the other board. So, we've clearly got a problem here on the other board. So, if it's not the coils and it's not the jungle, what is it? Yeah, that's weird. I wonder if the oscillator's running off frequency, maybe. I don't think so, though. Could be. Because the killer would kick in, wouldn't it? Huh. Okay, so the caps were changed on the other one, so that's not it. So I checked the resistors, none of them are open. I'm starting to run out of ideas. So anyways, I'm going to pull all that crap back off and put it on the other board. And next up would be that crystal. Maybe adjust the trimmer and see what happens. Alright, so I pulled 4 of the ceramic capacitors in there. The 4 that I think are the most important for color demod. They're over here, and I tested it both on resistance and on this meter, and they all test fine. They're all perfect. Now, obviously I can't test for leakage, but what's the likelihood of that? So, they all test perfectly fine. And I went through the resistors again, all the way down this side, and all the way up and around this whole area, including the potentiometers. They're all fine. I'm not seeing anything open, bad. So, I think at this point, I'm going to go ahead and end the video because I don't really have a solution at the moment. Also, I'm trying to find the factory service manual to see if it goes into detail on how the demod works with this chip. And I can't find the factory service manual anywhere. Also, since this is a 0212CE, it's proprietary, and I can't find the datasheet anywhere either. So it's like a double whammy. And I know the datasheet exists because the SAMs had to get it. Where are they going to get all this information? So they were able to get the data on these chips at one point in the past, but I can't find it now. So I think I'm at the end of the road here. If anyone has any ideas, or if someone can find the factory service manual or even the datasheet to this chip so I can figure out how the demod works. Because if I can figure out how the demod works in this chip, I might be able to apply external voltages or something somewhere to force the chip to, you know, maybe it's the color killer circuit. I don't know. The color killer is looped through here. But again, I don't know because I don't have the data sheet to that chip. And the SAMs does not go into detail on how the color circuitry works. So, anyways, if someone's got any input or information they can follow up with and help me out, that would be greatly appreciated. But in the meantime, I think that's it for this video, and not very many things are unfixable as far as I've run into, but this might be one of them. Well, I hope you learned something, or not, because I didn't really learn much about how difficult this thing is. Anyways, now I'm ranting. Anyways, thank you for watching. If you have a comment, please feel free to leave one. And don't forget to hit the like and subscribe and all of that fun stuff. Until next time, guys.